Hey there, I'm Lockie, a Microsoft technical trainer. It's good to have you here. In this video series, we are going to be looking at Azure ExpressRoute in all of its forms, how to deploy it, how to set it up, and what it's used for. As an enterprise solution where you need resiliency, you need speed, and you need stability above all else, ExpressRoute offers the best of all worlds. We're going to begin with a simple look at ExpressRoute at a high level. How circuitry works, what you need to do to get it provisioned, and how to actually get it deployed. We're also going to be looking at some of the alternatives to ExpressRoute, or I suppose the alternative flavors, ExpressRoute Direct, and a few different features that we can add on, such as Global Reach and FastPath. Coming up, we're going to be looking at ExpressRoute at a relatively high level. Mostly what we're focused on is what it is and how you use it. We need to look at some of the capabilities that it has and some of the different connectivity modes that are available to you depending on what you are needing to do and what your particular requirements are. Whether you are interlinking with a partner or if you are setting this up on your own terms, ExpressRoute offers a lot of flexibility. So let's establish the baseline and work from there. In front of us here, we have all the constituent components that make up an ExpressRoute connection. On the left-hand side, we have the physical site we are looking to connect to. This is important. ExpressRoute runs over physical cabling. Second, we have the Microsoft Secure Edge, our routers that exist at the edge of the Microsoft Azure ecosystem that allow you to ingress and egress traffic in a private manner. We also have Microsoft services that have public addressable IPs, such as Microsoft 365, SQL servers, storage accounts, etc. And we have our private address space in Azure. ExpressRoute is able to make use of and route traffic to pretty much everything you see on the screen here. So the first step to getting ExpressRoute up and running is to provision an ExpressRoute circuit. Now this circuit is typically going to be connected via a partner of some kind. Different geolocations will have different partners that are available to you, so make sure you check the documentation over on learn.microsoft.com for what partners are available in your region. Regardless, you will link up in one of our co-locations that we've worked with these partners to set up a connection into the telecommunications Meet Me room. Meet Me rooms are secure places for us to connect in across two different physical connections. The partner will then create what's called a cross-connect through the Meet Me room into Microsoft's routers and directly into the Microsoft Edge. So by default, an ExpressRoute circuit has high availability because two connections, and it is resilient, being managed by a third party on your behalf. This is just the pathway to carry traffic though. What traffic you wish to actually pass across is up to you. We could establish a connection into a gateway in a virtual network, and you can move private traffic. Or you could establish a connection through to the public ecosystem and make connection to Azure publicly addressable IPs. It's your call and it's yours to make use of. There is one thing that is importantly missing from this diagram, and it is the internet. If you are physically located in a colo, at no point are you traversing the internet. You are passing straight cable from your router into the Microsoft Secure Edge and passing all the way through. This is a private connection running over private fiber. Extremely important for an enterprise to have that level of privacy, security, and visibility over the stability of their connection. Now, what we've just looked at is the idea of a service provider model within ExpressRoute. Whether you are working within a cloud exchange co-location or you're working with a partner across a WAN, the idea is that you are able to have a private connection through to one of our co-locations and into the cloud. Now, these co-locations are not necessarily located just in Azure regions. We actually have many edge endpoints for you to enter across the globe. So make sure you check the documentation and work with a partner that's close to you to get the best performance out of your circuit. Up ahead, we're going to be looking at ExpressRoute Direct, a great option for businesses and enterprise that need a little bit more control or speed, or have some specialty needs but still require the use of a privatized connection like what ExpressRoute offers. We're going to jump straight into it and look at how the different ExpressRoute connectivity model of Direct is able to facilitate some interesting scenarios for your business. Unlike a service provider model with ExpressRoute that is focused on getting someone to facilitate connections on your behalf, effectively getting you from A to B via whatever means necessary, ExpressRoute Direct is focused on giving you as much control as possible. The service provider model within ExpressRoute typically runs on layer 3 of the OSI stack. ExpressRoute Direct, however, is on layer 2, and what we're going to be provisioning is not a circuit, but a port to run your connections across. So in front of us here, we have pretty much everything that fits together to make an ExpressRoute connection happen. On the left, we have our on-premises network. We have a telecommunications meet-me room, which allows for private interconnects between different providers. We have the Microsoft Secure Edge, which is our routers that make up the edge of the Azure ecosystem. We have publicly addressable IPs, such as the Microsoft 365 or SQL database, and a private Azure network. This is everything that we can need to connect ExpressRoute together. Let's look at how ExpressRoute Direct passes through into our environment. When you put in a request to provision ExpressRoute Direct, you are going to provision a port pair. So on the secure edge, you are going to be given 2 fiber ports. You will then need to run SFP fiber lines from here directly through. A partner may assist with some of the cabling, but the key thing is what is being exposed to you is not being translated through other devices. This is a direct fiber run. This means you are able to monitor things like light level and how things are actually propagating in an environment. You're dealing with extremely low level connections. Now at this stage, what we have is effectively a tunnel. We can send traffic across this by provisioning ExpressRoute circuits on top of this. So, as a core example, let's say I have to get a certain amount of traffic through to my Azure private environment. We're going to pick a number, maybe 5 gigabit. This project needs dedicated bandwidth 100% of the time, and it must be up. Let's do it. What we do is we provision a circuit and run this 5 gigabit circuit through the Microsoft Secure Edge and into a virtual network in Azure. But separate to that, I could run, say, a 40 gigabit circuit through to some public IPs as a separate connection. These are Q&Q encapsulated and are separate from one another. And note the numbers here. A standard ExpressRoute circuit taps out at 10 gigabit per second. ExpressRoute Direct ports come in either a 10 gigabit or 100 gigabit port pair, which allows us to provision either many small circuits up to 100 gigabit or one giant circuit that carries a huge amount of traffic. Different enterprises will have different reasons for provisioning different types of SKUs across an ExpressRoute, but the level of flexibility that we have in terms of scale and size is extremely vast with an ExpressRoute Direct compared to even a standard ExpressRoute via service provider. In front of us here, we have a quick summary, just comparing the service provider model to the ExpressRoute Direct model. Not every customer is going to need what ExpressRoute Direct offers, but it's there as an option. If you require 100 gigabit of traffic, or you need to be able to go through and provision multiple circuits within a single tenant for different purposes with dedicated bandwidth types, ExpressRoute Direct offers that for you in a significantly easier package compared to provisioning multiple ExpressRoute circuits. If this sounds like it's up for you, I recommend looking at it. Certainly, an ExpressRoute circuit model is available to all customers regardless, and it does have some advantages. For example, we can actually use MPLS or Ethernet connections and don't need to do direct fiber runs. That's one of the things that we can do with a service provider model. Each environment will work slightly differently, and each enterprise is going to make a slightly different call about what's right for them. But know the options and evaluate your choices before you commit. We're looking at ExpressRoute circuits. Regardless of whether you are deploying a circuit on its own or you've built out an ExpressRoute Direct, you are going to need to provision something to carry the traffic across. The circuit is that something. There's different SKUs, different tiers, different options that are available depending on what it is you're looking to do with your business. So knowing the different options there, making sure you pick the right one is incredibly important. Let's start at the top with a little bit about what is available and how you can make the right choice of SKU. SKUs are basically t-shirt sizes. You pick the size that fits and meets your business requirements. Most customers, at least as a starting point, will look to the standard SKU. This gives you access to all Azure resources within a particular geopolitical region. Now, geopolitical areas like this are, for example, Australia East and Australia Southeast. These are paired in a geopolitical region together. Certain US regions will be paired together as well. We use these different geopolitical mappings for failing over between different regions. For a full list of how the mapping is set up, head on over to the Microsoft Learn documentation and search for ExpressRoute within there to find more details. Now, if you instead need to go into just a single region, we don't really care if we're going to a full geopolitical, but just one region, you can actually set up an ExpressRoute local circuit. Local gives you egress to just one location, one or two. There's some caveats on there as always. But what it provides is a very low cost option for very targeted ingress and egress. On the other side of things, ExpressRoute Premium allows us to have more routes and to have connectivity to many more regions at the same time. So, depending on what your enterprise needs, you can pick accordingly. Either something that is very targeted to a single region, something that is global, or something that is mapped just to the regions you might be consuming in Azure. Now, the next thing you'll need to pick, once you've chosen the type of SKU you're looking for, is where you're going to deploy it. If you see the yellow locations on this map, these represent Microsoft Edge nodes, where our secure edge is actually located. And there are significantly more edge locations than there are regions. This allows us to have scale and allows you to hop onto the Microsoft private backbone as quickly as possible. Let's say you are a customer in Perth. There is a Perth Edge site that you can peer into with your ExpressRoute that allows you to access the Australia East and Australia Southeast regions. Well, depending on what SKU you pick of the circuit. So choosing a peering location and partner to work with, as well as picking the right SKU, are both considerations you'll need to kind of make back to back. Now, the third big thing to consider is how you're going to get charged for the thing. ExpressRoute can be charged in an all-you-can-eat buffet style unlimited data pack, or can be picked in a monitored metered data pack. There are different break-even points for this, and I recommend looking at the pricing page or the pricing calculator to work out for your company what is going to be the right choice. Additionally, the ExpressRoute Premium add-on is extremely useful if you're looking to access some additional services. Details for this are located in the Microsoft Docs. Now, deploying an ExpressRoute circuit does take a little bit of time, but what I'm going to do is jump into the portal and show you some of the configuration options you will have on hand when you're ready to go. Here in the portal, I've selected ExpressRoute circuits. I just want to be able to show you the process of actually provisioning a circuit. In total, it can take a number of weeks to get everything up and running, make sure your cable's in the right spot, but at the very least, we can take a look at how the provisioning actually works in the portal itself, because much of it is done beforehand before the cabling is run. We hit create here, and this will take us into a selection where we can begin to choose things like where it's going to be deployed, what region we're going to, all of the same sort of stuff that we're looking at elsewhere. I'm just going to pick ER001. Now, the next thing you'll be able to pick is a port type. If you are using ExpressRoute Direct and you've already configured ports there, select Direct, and then make sure you just pick the ExpressRoute Direct details. If you are a customer setting up a more normal ExpressRoute circuit on its own, choose Provider, and then look at the list of providers that are available. Depending on the region you have selected, you will find different providers there. So simply pick and choose which provider you are actually working with in the drop-down list. You can then pick your different SKU, depending on what it is you're looking to deploy, and the different billing model that you wish to make use of. All of this is simply configurable through here. Don't forget that you can always hit this Learn More About Circuit Types to get some more details about the difference between a service provider model and an ExpressRoute Direct model. Now, the other thing that we need to look at configuring is the gateway itself. We need to be able to land that traffic somewhere. If you configured a VPN gateway before, this will look very familiar. If we search for an ExpressRoute gateway, you'll find that nothing comes up immediately. This is because it's actually just a network gateway. Head into my virtual network gateway here. I can hit Create. And the process of creating a virtual network gateway for use with ExpressRoute is literally the same as a VPN one. The only difference is that we select ExpressRoute instead. We still need to give it a point to land. This public IP address is just a reference point in the Azure ecosystem, and it's not something that's going out to the internet. There's some interesting details around this, and you can view more about how that functions in the Microsoft documentation. Once you've selected the things you need, you can hit the gateway, hit Create, and you'll be ready to go and land that traffic in your virtual network. We're going to be looking at ExpressRoute peering. This is something that you need to configure to choose what actually goes across your ExpressRoute circuits. There are two different types of peering we'll be looking at today. The first is private peering. This is what will handle your private IPv4 or IPv6 traffic. And the other type of peering we'll be looking at is Microsoft peering. For any publicly addressable IPs that are located in our Microsoft data center range, this could be Microsoft 365, SQL, could be a storage account, anything like that, this is covered by Microsoft peering. It's up to you on what you want to use, private peering, Microsoft peering, or both. And I'll show you how to configure things so it works the way that you need your business to function. Let's dive into it. In front of us here, you can see a diagram that represents an ExpressRoute circuit. Whether direct or provisioned via a service provider, the principle remains the same. A connection that is established in your on-premises physical location, across the co-location through the partner edge and into the Microsoft edge, that then eventually reaches Azure and the Microsoft ecosystem as a whole. One connection across an ExpressRoute can carry both Microsoft peering traffic and private peering traffic. You can use one or both or the other, whatever makes most sense for you. We're going to cover private peering first because this is pretty much where most businesses at least start the conversation. Private peering is how we actually establish that connection into our private address space. A virtual network is the easiest way to think about it. You'll need to establish a few different things. The first will be a peer ASN. This is going to be the ASN number that you will use for any BGP routing with your internal routers there. Once you have this established, you'll need to pick whether you're using IPv4 or IPv6 and a couple of other options around where you're going to be landing traffic. So, primary and secondary subnet. We do also have the ability to assign a VLAN ID, and I recommend going through and choosing this so your on-premises knows what this is associated with. Ultimately, the goal here when we are setting up the peering is to create a package in a border gateway protocol community that we can then pass along back to our on-premises devices so they know what is actually located up in Azure. Now, once you have this private peering established, we just need to go through and actually do the connection itself. If you have an ExpressRoute circuit provisioned, head into your Connections tab, hit Add on that one there, and then simply go through the process of selecting what virtual network is going to be connected up. You will require a gateway subnet to be able to put that in, and will need an ExpressRoute gateway either provisioned, or you can provision one as you go. Once the gateway is there, you'll be able to configure a few other important things, including routing weight. Different routing weights will allow you to direct traffic accordingly, so you can have active and passive models, and we can look at different resiliency models within your private stack. So private peering is one type of connection we can establish. Let's now look at Microsoft peering, because many of the initial steps look near identical. We're still going to be going through and configuring things like ASN, IP ranges, that sort of stuff. But what we need to then configure is exactly what traffic you want to carry. Microsoft peering begins with a VLAN ID, a primary subnet, an ASN. There's a few different things that you will need to process through. These IP prefixes you are picking, though, do need to be valid IP prefixes. So you'll need to work with a registry on acquiring and assigning those IP ranges. Once this process is done, though, and you have that IP space carved out, we're ready to go and start configuring what we can call a route filter. Now, route filters allow us to select exactly what traffic from the Microsoft ecosystem you wish to carry across that ExpressRoute circuit. Let's have a think for a moment. Let's say I am a customer that is looking to make use of services that are located in Australia East, and specifically I am looking at a subset of services focused around maybe storage. I could choose to grab the BGP community that is reflective of just storage, or storage in Azure East, or Azure Australia East, and pick the community that most reflects the traffic that I wish to consume across this circuit. By no means do you have to hit select all and grab everything, because there are many good reasons that you would want traffic to route across the internet. As an example, Microsoft 365 services such as Exchange Online, SharePoint, and the like, they are designed and are best optimized when routed directly across the internet. So it'll only be in specialty scenarios that we would want to use an ExpressRoute circuit for that. Hence, adding the route filter allows us to control exactly what traffic flows across that circuit. Once you have gone through and established the route filter there, pick the appropriate region, pick the specific communities that you wish to make use of, and choose that subset and assign it to the circuit. You can check the documentation over on learn.microsoft.com for more details about exactly what is contained within each of those BGP communities, and also where you can get information about what IP addresses are going to be contained within each of those communities themselves. We are going to be looking at ExpressRoute resiliency. There are some simple architectural changes that you can make to make your ExpressRoute work better. Whether this be for speed requirements, whether this be for uptime requirements, or simply through distribution of traffic across multiple sites, we can look at different ExpressRoute deployment configurations in order to facilitate a whole range of different scenarios. We're going to be looking at some resilient architecture and a little bit on encryption as well, which is an important topic to cover. So let us begin. On the screen here, I have a whiteboard with what I found a fairly common customer scenario when I was out in the field. We have two different data centers. We're going to call them R1 and R2 reflecting the two different regions that we're in. These may be close geographically to one another or could be disparate, but the point is that we have two different regions that we have available to us. So what options do we have to increase resiliency within our environment? Let's take a single ExpressRoute circuit as our first port of call. An ExpressRoute connects through a MeetMe and into your Azure environment. I've simplified things here to look at just the private peering side of things. At this moment, what we actually already have is a resilient, high availability connection. Azure ExpressRoute is active by default. You have two different subnets and two different endpoints that you are able to reach. So we can load balance between those two with waiting or we can use one as an active and a second as a standby to ensure the traffic remains up. But what if this isn't what you're looking for? That's okay. We've got some resiliency mechanisms we can go above and beyond. Let's look at region 2 now. I can have an ExpressRoute begin in region 2, carry through the local meet me, and into Azure in the exact same way I have in my primary region. Then through weighted pathing, I could have maybe a connection between these two data centers and use ExpressRoute and fail between the two. We can have disparate pathways with different types of weighting, and you can get really complex with this. All it comes down to is understanding your business needs and how you actually need to have this up. The more ExpressRoutes you have, it is a fairly costly option compared to something like a VPN. So, what is going to be the best option for you? In this example, if we were to have peering between these regions and we have connectivity between our two on-premises regions, we've now established a chain where if any one of these ExpressRoute physical locations fail, whether it be on your side, our side, a cable going down, someone cutting a wire, whatever it is, you still have a secondary pathway. Weighting in BGP communities will make a big difference in terms of how this all fits together. But we don't need to go as complex as this. If you are picking an ExpressRoute circuit in a single region, I still have a couple of different things that you can do to ensure uptime is there in a really easy way. When using private peering, there is actually an option that is on by default called bidirectional forwarding detection. BFD is able to detect if an ExpressRoute goes down very quickly. Now, if you have BFD turned off, which is something you would have to do because it's configured by default, what will happen is that an advertisement will go across, and effectively if the route goes down, this top line gets crossed out, we need to wait for the BGP community to effectively request that it's looking for a refresh of its routes. With BFD enabled, we're able to report that back actively if something goes wrong. As long as your devices support BFD, this is still one of the best ways to ensure quick failover between the two different connections, taking it from potentially multiple minutes down to less than a second in terms of cutover. The other thing that we can look at in terms of high availability is look at disparate pathways. ExpressRoute is designed to run across your private fiber that has been provisioned. Why not provision something like a VPN connection as a secondary failover? This VPN connection is going to traverse across the internet, which means we now have two diverse pathways, one through your private infrastructure and a failover that you can follow across your backup infrastructure. This gateway can also be dual purpose. In this example here, we actually have a VPN gateway not only acting as a connection to a secondary site, but also as a failover in case the ExpressRoute ever goes down. So think about how you can architect potentially using a VPN connection. Whilst we can't achieve necessarily the same speeds that we can as an ExpressRoute, as one of my customers once said, I'd rather it be up than it be a little slow than it be down at all. All right. We've talked enough about availability. I want to talk to the elephant in the room around encryption. ExpressRoute is designed as a private connection with trusted sources carrying that traffic across. But what it isn't is explicitly encrypted. Now, this is because encryption adds overhead. We have given customers a couple of mechanisms to add encryption if that is something that you are explicitly required to, whether it be through policy or through law. The simplest way to add encryption over the top of an ExpressRoute is to use a VPN connection. Establishing a VPN gateway in Azure and a VPN in your on-premises, you can create an IPsec tunnel between these 2 points. Nice and simple. As an alternative, you can actually carry over the top of an ExpressRoute Direct MACsec peering. As it's running at layer 2, we are able to support layer 2 encryption and have a level of encryption over the entire port pair, which you can then establish circuits on top of. Both options are available to you, just depends on what you're looking to configure. The big thing to remember is to establish this within the business early if this is going to be a requirement for you. Easy to set up at the beginning, it can be difficult to put in later, so get it right early on and you'll be set. Now, ahead we are going to be looking at ExpressRoute Global Reach. This is one of the additional services you can add on to an ExpressRoute circuit, depending on what it is that you need to make use of. We're going to run through exactly what Global Reach is, the scenario that it was designed for, and how you can use it to connect disparate sites together with ease. Right here is the pitch example for where and why you would use ExpressRoute Global Reach. On the left-hand side, I have my San Francisco home base. And on the right-hand side, I have a London home base. Both of these sites are connected already to the Azure environment using ExpressRoute. Why don't we leverage what we've already got? ExpressRoute Global Reach allows us to connect any two ExpressRoute circuits together and effectively bypass the Azure Virtual Network infrastructure and just connect straight from one to another. If what you need is a direct connection between two sites, this is what Global Reach is designed to do. So this is kind of the basics of how we would set this up. But let's talk practically. Where would we likely use something like this? Well, if it's linking two sites, sure. But more commonly, this is what I tended to see. I have 3 separate global sites. One in Silicon Valley, one in Tokyo, and one in Hong Kong. All 3 sites have completely different connection types and completely different sets of providers. I don't have a consistent person across the group. But what I do have is the Microsoft Global Network in the middle. What I can do is use my ExpressRoute connections as a communication tactic between these sites, interconnecting them and allowing them to then forward in to an existing WAN. So, in the US, I have my wide area network already connecting my US sites, and then I can simply use ExpressRoute as a way to forward that WAN into the broader network. Now, where this is useful is we don't need to then set up virtual network connectivity or anything like a vWAN hub in Azure. We can actually do this entirely with ExpressRoute. So, it's a bit of a specific scenario for us to use this, but if you need it, it is so useful to get yourself up and running. Configuring it, it's a breeze. Any ExpressRoute private peering connection can have added to it Global Reach by simply hitting the button there. Tell us what subnet you're going to be connecting into. There's a few things you'll need to put in place in the configuration, but once it's done, hit add. We know what we're connecting to, what ExpressRoutes we need to knit together, and the routing will be handled automatically. We are going to be looking at ExpressRoute FastPath, an interesting service that you can utilize as part of your ExpressRoute deployment for some pretty specific scenarios. This one's nice and short. We want to look at what FastPath is, and then we'll talk a little bit about the configuration and actually getting it spun up. ExpressRoute FastPath is designed for one particular scenario, but it's a scenario with a lot of versatility. On the left-hand side, I have my on-premises network. Now, let's say I'm an administrator over here, physically connected to the network on a workstation, and I want to remotely connect into my workstation that is located in the cloud. This could be a developer workstation, or maybe I'm remoting in to assist with administration. Typically speaking, the way that this connection would function would be to go across the ExpressRoute. It'll hit the gateway itself, and then it will redirect in. This is a control plane route. What FastPath supports is the ability to use this control plane purely for initial establishment of the connection. So let's say I am connecting in through to this virtual machine in the middle. The pathway will go as follows. 1, leave the on-premises gateway. 2, traverse across the environment until 3, I hit my ExpressRoute gateway in Azure. This then allows it to go 4, and establish across to the VM. But the next step that gets done, that information gets passed back, and any future connections across this immediately go straight across the data plane. We're talking a direct connection straight to that virtual machine. Now, this type of data path performance connection does require a very specific SKU because there is a hardware requirement, and it is the ExpressRoute Gateway version 3 in the ultra performance tier. So you need to have selected the correct gateway SKU to be able to use this. But if your scenario involves multiple connections across an ExpressRoute via a remote desktop or for scenarios similar to that, this is a great way to improve performance. When we're dealing with a desktop connection, every millisecond counts, and we can make the user experience significantly better through a simple shift like this. Now, to configure ExpressRoute FastPath, it's relatively straightforward. Whether it be through the CLI or the command line in PowerShell, all you need to do is run a simple command to grab the circuit that already exists and enable the ExpressRoute Gateway bypass. By doing that, FastPath will now be enabled, and you will be able to have that initial establishment put through the gateway and then a direct data path across, improving your performance. For more details about how to set this up in your environment, head to Microsoft Learn and look for the documentation around FastPath and how you can use it to optimize your remote connections. We're going to look at the troubleshooting process for an ExpressRoute connection. Now, not everything goes perfect first time. That's just the nature of life. So what I want to do is show you the tools and the data that you have available to make sure that you can test stuff out and that it's all working correctly. We're going to look at a little bit of provisioning, how you actually get stuff up and running, and what data you can fetch via the CLI. So let's start at the top. Right here, this PowerShell command, get ExpressRoute circuit. This is extremely useful because what it's going to return is all of the backend data for an ExpressRoute circuit that is currently provisioned. We'll be able to see information about location, ID, all the stuff that we would expect for an Azure resource. But what we also get is information around the service provider, the bandwidth that's been provisioned, and the location of it. Essentially, it's all of the data you need to actively identify an ExpressRoute circuit in its proper state. If you are seeing any issues with an ExpressRoute circuit, this should be your first port of call. Additionally, note things like the server status here. These different statuses for the provider and for the circuit itself tell you quite a lot. If something is provisioned, we know that it has gone through the provider already. If you have a circuit status of enabled, it means you've done the work on your side. So there is some specific meaning for those. Now, one of the easiest things you can do if you are seeing a failure in a circuit before you get on the horn to the support team and start contacting there, is just turn it on and off again. To reset a circuit, it's as simple as fetching the ExpressRoute circuit itself, make no changes, and then just set it again. This set process here, where you are going through and actually applying a change to an ExpressRoute, even if you don't make a change, will force a refresh of the configuration. And to force a refresh, we will need to take the circuit down and then bring it back up. If you ever see something in a failed state, do this first because it's the easiest fix and it doesn't require anything extra to kind of get up and running. All right, let's say we've got our circuit up and running, but the thing that's not working is the peering. We're not able to get private traffic or Microsoft traffic across. Well, to validate that, head to your ExpressRoute circuit and look along the bottom here. You'll be able to see a status, which shows where you're at in the process of provisioning this out, as well as what subnets are currently connected through. All the details will be there, including if you are working with a provider and a change has been made on their side. So always check this if you're seeing something odd with your peering. Now, for those that have worked in the network space for a while, you'll know that ARP tables are extremely useful. These operate at layer 2 of the network stack, and we get a lot of information around what is physically connected to what. You are able to fetch the ARP table for an ExpressRoute circuit to get interface details. You just make sure that things are what they say they are, and that things are returning and reporting correctly. If something could be solved by looking at Ethernet addressing in an ARP table, or there's information you need there, just go and fetch it. It's as simple as that. Now, the last one that I want to talk about is less troubleshooting and more verification. Whether it be that you are seeing slow performance or you want to test the limits of your ExpressRoute circuit, there is a specific toolkit for it. Look to Azure CT, which is the Azure Connectivity Toolkit. This allows you to test a range of scenarios with your network connectivity, not just pushing and pulling one packet, but different packets of different sizes to really just test the limits and make sure that things are working correctly. Tools like iPerf and PSPing are both going to work as well, so if you have some standardized tools, you can make use of those. But personally, I like this because the ability to go get link performance and run it across the ExpressRoute in this way really will give you some very solid information about how your circuit is functioning and if it is functioning up to spec.